So now today we are continuing mathematical induction problems under the same heading. Prove the following statements for all n belongs to n using principle of mathematical induction. Now the next problem is a plus d plus a plus 2d plus so on plus a plus n minus 1 into d is equal to n by 2 into 2a plus n minus 1 into d. So this is a question. We have to prove this. Now solution. As usual, we'll consider this as Pn. So Pn is this. Now P1, let us take P1. A is equal, on right side, in the place of n, you have to put 1. 1 by 2 into 2a plus 1 minus 1 into d. Now let us see LHS. LHS is equal to a. Now let us see RHS. RHS is equal to 1 by 2 into 2a plus 1 minus 1 is 0 d. 1 by 2 into 2a. 2 to get cancelled a. So we have seen that LHS is equal to RHS. Therefore, P1 is true. We have proved P1 is true. So this is A. Now, as usual, for some m belongs to n, we consider that the Pn is true. It is consideration. So, for some m belongs to n, let Pm is true. So this is true only. We are considering is true. So what is Pm? A plus, this all will remain same here, only thing here you get m. So this is m by 2 to 2a plus m minus 1 into d. Right. So this we have considered as true. Say B. Now we have to prove that P of m plus 1 is true. So to prove that P of m plus 1 is true, so let us write that P of m plus 1, which we are supposed to prove, okay, well in advance. So that is to prove, this has to be proved, that is to prove that a plus d plus so on plus a plus m minus 1 into d plus a plus, here the next successive terms we are writing. So m has to be replaced with m plus 1. So plus 1 minus 1 get cancelled. M plus 1 minus 1 get cancelled. So md you get is equal to that m has to be replaced with m plus 1. M plus 1 by 2 into 2a plus m plus 1 minus 1. Plus 1 minus 1 again get cancelled. 2a plus md. This we are supposed to prove. So to prove this, what we have to do? We have to add this a plus md on both sides of equation b. So for this, on adding a plus md on both sides of equation b. So now let us start this procedure. So now a plus d plus so on plus a plus m minus 1 into d plus a plus md. So on LHS side we have added, we have to even add on RHS side, is equal to m by 2 into 2a plus m minus 1 into d plus a plus md. So now we have to continue simplifying RHS until you reach to this expression. So this is equal to, now take LCM. So 2 is LCM. So m into 2a plus m minus 1 into d. Here by 1. So plus 2 into a plus md. So now you multiply 2am m into d md into m minus 1 plus 2a plus 2md. I opened the brackets by 2. So now this is equal to 2am plus md into m square d, or else you can do one thing. This is equal to 2am plus md is common here and here, so take md common, then you have m minus 1 plus 2, md taking common m minus 1 plus 2, which will become m plus 1 plus 2a by 2. Now here and here take 2a common, here and here if you take 2a common, you get m plus 1 plus md into m plus 1 by 2. Now on the whole you can take m plus 1 common. So taking m plus 1 common on the whole, you get 2a plus md. By 2. See what we are supposed to prove, we have proved it. So you can give all further conclusions. Therefore P of m plus 1 is true. Therefore using principle of mathematical induction, P of n is true for all n belongs to n. That finishes the problem. Now our next problem, Pn a plus ar square plus so on plus a into r power n minus 1 is equal to a into r power n minus 1 by r minus 1. This is a problem relating to some of the n terms of geometric progression. The previous problem is related to some of the n terms of arithmetic progression. So the beginning is same as this. We'll begin with Pn. Okay, now solution. Now we'll see for P1. So A is equal to A into R power 1 minus 1 by R minus 1. Now let us see LHS equal to A. RHS equal to A into R power 1 is R minus 1 by R minus 1. Now that R minus 1 get cancelled. So you get A. So you have seen that LHS is equal to RHS. So therefore we can conclude P of 1 is true. Now let us assume for some m belongs to n, the given statement is true. Let for some m belongs to n, P of m is true. Therefore, the statement you are taking as granted is A plus AR plus AR square plus so on plus A into R power m minus 1 is equal to A into R power m minus 1 by R minus 1. So we have considered it is true. So this is A, say this is B. Here these are the steps. We have completed step A, now we are in step B, like that. Now to prove that P of m plus 1 is true. So that is to prove P of m plus 1 A plus AR plus AR square plus so on plus A into R power m minus 1. Immediate next successive term in the series you have to take. For that you have to replace m with m plus 1. So if you replace so, m plus 1 minus 1 plus 1 minus 1 get cancelled. So you get A into R to the power of m. And this side that m has to be replaced with m plus 1 so that you get this. So you are supposed to prove this. In order to prove this, we take the help of step B and we'll add A into R power m on both sides of B. So that's what we are going to write now. So adding A into R power m on both sides of equation B. So this is equation B. For this we are both sides adding A into R power m. So here plus A into R power m will come is equal to this plus A into R power m. So A into R power m minus 1 by R minus 1 plus A into R power m. So now we have to further simplify the RHS until you reach to this. So let us see what happens. So now this is equal to A into R power m minus 1 by R minus 1. Now if you go for LCM, R minus 1 is LCM. So A into R power m minus 1 plus R minus 1 because here there is 1, so r minus 1 into a into r power m. Now you open up the brackets, a into r power m minus a plus a into r power m into r, a into r power m plus 1 minus 1 into a into r power m gives you a into r power m divided by r minus 1. Now this plus a into r power m minus a into r power m get cancelled. Then you are left with a into r power m plus 1 minus a by r minus 1. Now if you take a common, then a into r power m plus 1 minus 1 by r minus 1. See, we are reached the same to which we are supposed to reach. So we have finished the problem. There is a matter. Further conclusions you have to give. See, this is C. Therefore, P of m plus 1 is true. So this is step C. So from A, B, C, using principle of mathematical induction, P of n is true for all n belongs to n. That is the final conclusion. So now, what is our next model problem is, in all these problems which we have proved so far, nth term is mentioned, right? That nth term is mentioned. Sometimes in some problems, the examiner will not mention the nth term. In such case, it is student's responsibility to find the nth term first and to go to the procedure next, because without nth term in the series, you cannot start the mathematical induction procedure itself. So please do remember, students, there is no nth term mentioned in the series. You have to find the nth term first and you should go for further procedure. So for this kind of question, I am taking one problem. That problem is, wait for 2 seconds. Right. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms is equal to n into n plus 1 into n plus 2 into n plus n into n plus 1 into n plus 2 into n plus 3 divided by 4. So chalo, we'll start now. You observe this series, the nth term didn't mention. So you have to find the nth term. So for that you may use some general observation or you may use some mathematical calculation. Do what it may be. Downloading the exact nth term is most important. If we have taken the wrong nth term, the problem will go wrong. It is a very simple formula. So for this, just I am observing and I am saying, see, the first factors of each term are the successive natural numbers beginning from 1. See, 1, 2, 3 and so on. And the middle factors, if you see, 2, 3, 4 and so on. So for last factors, if you see, it is 3, 4, 5 and so on. So all these are in arithmetic progressions. So for if you find an for this arithmetic progression, a plus n minus 1 into d is 1. So 1 plus n minus 1, which is n. Now, if you find an for this middle factors, an is 2 plus n minus 1 into d is 1. So, 2 plus n minus 1, which is n plus 1. So, obviously, here you get n plus 2. So, therefore, the nth term of the given series would be the product of all these nth terms, that is n into n plus 1 into n plus 2. Right? So, because you have found the nth term successfully by using a simple calculation, so now we are not deficit with any factors, so that you can start the mathematical induction procedure. So, now take Pn, this so on goes up to m terms, but here at this stage you should not write up to n terms because you found the nth term. So, you have to write the nth term here. So, the nth term which you have found successfully is n into n plus 1 into n plus 2 is equal to that. Now, let us continue as it is. So, now P1 is 1 into 2 into 3 is equal to, that side n has to be replaced with 1. So, 1 into 1 plus 1, 2 into 1 plus 2, 3 into 1 plus 3, 4 by 4. Now, take LHS, which is 1 into 2 into 3, which is 6. Now, take RHS, 4 get cancel, again it is 1 into 2 into 3, which is 6. So, LHS is equal to RHS. Therefore, P of 1 is true. So, we have proved that P of 1 is true. Say this is step A. You have finished step A successfully. Now, as it is for some m belongs to n, let P of m is true. For some m belongs to n, let P of m is true, which we are considering as true. True is true. So, here P of m, the same, here m into m plus 1 into m plus 2. This is m into m plus 1 into m plus 2 into m plus 3 by 4. Chalo. So, this is step B. Now, we are supposed to prove that P of m plus 1 is true. So, to prove that P of m plus 1 is true, so what is P of m plus 1 that we are supposed to prove? Here let us write, that is to prove P of m plus 1, 1 into 2 into 3 plus 2 into 3 into 4 plus so on, plus m into m plus 1 into m plus 2, that m has to be replaced with m plus 1. So, m plus 1, m plus 1 plus 1, m plus 2, m plus 1 plus 2, m plus 3. Even that side also m has to be replaced with m plus 1. So, you get m plus 1 into m plus 1 plus 1, m plus 2, m plus 1 plus 2, m plus 3, m plus 1 plus 3 is m plus 4. divided by 4. You are supposed to prove this. So to prove this, we have to add this quantity on both sides of equation B. So on adding m plus 1 into m plus 2 into m plus 3 on both sides of equation B. So now let us start. 1 into 2 into 3 plus 2 into 3 into 4 plus so on plus m into m plus 1 into m plus 2. We are adding now plus m plus 1 into m plus 2 into m plus 3 is equal to, as we have added this side, even we have to add that side. So that place is not sufficient. I am writing here m into m plus 1 into m plus 2 into m plus 3 by 4 plus you have to add the quantity which you have added on LHS, which is m plus 1 into m plus 2 into m plus 3. Now if you take the LCM 4, then what do you have? M into m plus 1 into m plus 2 into m plus 3 plus 4 into m plus 1 into m plus 2 into m plus 3. Now take m plus 1 into m plus 2 into m plus 3 common. So if you take common, then you will have m plus 4. Because here there is m left over, here there is 4 left over. If you take this entire expression common, you get m plus 4. So see the same thing you got which you are supposed to prove. So therefore P of m plus 1 is true. Step C. So from A, B and C, using principle of finite mathematical induction, P of n is true for all n belongs to n. This is a conclusion that you have to give without fail to get good marks. So next this series kind of problems we did so far. So now we are going to do some divisibility based problems. So in divisibility based problems, we have to prove that certain expression is divided by certain number which will be given for all n belongs to n. How that procedure will go, I will explain taking 2 to 3 problems so that you can understand very clearly. So coming to the question, prove that x power n minus y power n is divisible by x minus y for all n belongs to n using principle of mathematical induction. This is the question. So we are supposed to prove that for all n belongs to n, x power n minus y power n is absolutely divisible by x minus y. So let us begin. Solution. P of n, x power n minus y power n is divisible by x minus y. Now P of 1, In the place of n, you have to put 1. That is x power 1 minus y power 1 is divisible by x minus y. X power 1 minus y power 1 means it is nothing but x minus y. So, x minus y is divisible by x minus y. X minus y is divisible by x minus y. As we have a number theory property that every number is divisible by itself, so obviously x minus y is itself divisible by x minus y. So that P of 1 is proven to be true. Therefore, P of 1 is true. Now, as it is for some m belongs to n, we assume that P of m is true. So, P of m, x power m minus y power m is divisible by x minus y. As it is divisible by x minus y, when x power m minus y power n is divided by x minus y, you get some quotient, say q, and the remainder 0. So here I am showing, you see please, for better understanding purpose, I am writing this. When x power m minus y power m is divided by x minus y, as you are agreeing this is completely divisible by x minus y, you get some quotient q, and finally you get the remainder 0. Therefore, by using division algorithm, of polynomials, then you get x power m minus y power m, dividend is equal to divisor into quotient plus remainder. Division algorithm, I suppose you all know, dividend is equal divisor into quotient plus remainder. It is applicable for numbers as well for polynomials. So this implies x power m minus y power m is equal to x minus y into q. So you have reached this stage when you have accepted that P of m is true for some m belongs to n. So this is B. So this is A. Now to prove that P of m plus 1 is true, so to prove that P of m plus 1 is true, so that is to prove that x power m plus 1 minus y power m plus 1 is divisible by x minus y. This is our destination. We are supposed to establish this. For this, what I am doing, wait and see. So first and foremost, take the expression x power m plus 1 minus y power m plus 1. So take x power m plus 1 minus y power m plus 1. Now which is equal to x power m plus 1 is x power m into x minus y power m plus 1 is y power m into y. Now x power m into x, now add and subtract x power m into y. If you add and subtract same quantity to the given expression, there won't be any wrong. So here I am adding and subtracting x power m into y. So minus y power m into y. Now here and here take x power m common, then you get x minus y. And here take y common, you get x power m minus y power m. Now x power m into x minus y plus y into, in the step B we have seen that x power m minus y power m is some q into x minus y from step B. You check the step B, we have seen that x power m minus y power m is equal to q into x minus y. So now take x minus y is common, then you get x power m plus qy. So as it is a multiple of x minus y, it is obviously divisible by x minus y. So therefore it is clearly divisible by x minus y, because it is a multiple of x minus y. X power m minus y power m, x power m plus 1 minus y power m plus 1 is divisible by x minus y. Therefore p of m plus 1 is true. Therefore, using principle of finite mathematical induction from A, B and C, we can conclude that P of m plus 1, P of n is true for all n belongs to n. That means x power n minus y power n is always divisible by x minus y for any natural number n. Now, we will do one more problem under divisibility category only. So we are now I am taking numbers. So prove that 49 to the power of n plus 16n minus 1 is divisible by 64 for all n belongs to n. So we have to prove that this is a problem. Why again why to read time waste? So now let us start solution. So P of n is 49 to the power of n plus 16n minus 1 is divisible by 64. Now let us see whether it is true for n is equal to 1. Now P of 1, 49 to the power of 1 plus 16 into 1 minus 1 is divisible by 64. Now let us verify whether it is true or false. Now let us take 49 to the power of 1 plus 16 into 1 minus 1, which is equal to 49 to the power of 1 is 49. Plus 16 into 1 is 16 minus 1, which is 49 plus 15. 49 plus 15 is obviously 64. So 64 is divisible by 64. As every number is divisible by itself, 64 is itself divisible by 64. Therefore, P of 1 is true. Now let for some m belongs to n, P of m is true. So, what is that P of m which you are considering as true? I will write here. P of m which you are considering as true. that is 49 to the power of m plus 16m minus 1 is divisible by 64. Again, using that same division algorithm, as this expression is divisible by 64, this expression is a multiple of 64 for some integer k. In the previous problem, polynomials are involved. In the present problem, integers are involved. So, as this is divisible by 64, this is equal to 64 into k. See, if it is divisible by 64, it is obviously a multiple of 64. See, we have seen the division algorithm, because the remainder would be 0. So this is step B. Now to prove that P of m plus 1 is true, so what is that P of m plus 1 which you are supposed to prove? I am writing it. That is to prove that 49 to the power of m plus 1 plus 16 into m plus 1 minus 1 is divisible by 64. This we are supposed to prove. 49 to the power of m plus 1 plus 16 into m plus 1 minus 1 is divisible by 64. So how the proving procedure will go, please observe. So 49 to the power of m plus 1 plus 16 into m plus 1 minus 1 I am taking. This is equal to 49 to the power of m plus 1 can be written as 49 to the power of m into 49. Obviously x power m plus n is equal to x power m into x power n. Now plus, now using distributive law, if you multiply, or you can say opening the bracket, then you get 16 into m plus 16 1 is 16, minus 1 remains same. Now here a tricky step will be involved. That is very simple. From equation B, what we do is, as we have considered it is true, what we do is from equation B, we take this 49 to the power of m value, so that you get by transposition 49 to the power of m is equal to 64k minus 16m plus 1. So from B you can easily see that. So now I am replacing this 49 power m value with its equal value that can be attained in the step B. So 49 power m value is 64k by transposition minus 16m plus 1. This is the equal value of 49 power m. Now here into 49 remains same. So into 49 plus 16m plus 15. 16 minus 1 is 15. Now if you open the bracket, 64 into 49k minus 16 into 49m or minus 16m into 49 makes no difference, plus 49 plus 15, right? So if you see in each term 64, then you can take 64 common and you can conclude it is a multiple of 64 and hence it is divisible by 64. That is my intention. Please see, according my intention I am manipulating the things. So this is equal to 64 into 49k minus. Now what you have to do is, here you see 64k into 49 we have written, minus 16m into 49 we have written, plus 49 we have written, plus 15 we have written. This number we have to take here. This we did not write now, so I have written there. Now what I am going to do is, here and here I am taking minus 16m common. So if you take minus 16m common from here and here, then you get 49, as you have taken minus common, so here you get minus 1, because minus into minus plus 16m, plus 49 plus 15 is 64. So now it is equal to 64 into 49k minus 16m into 48 plus 64. Now 48 can be written as 12 into 4. 12 fours are 48. So see, I am taking this. So 64 into 49k minus, if you write this is 12 fours are, 4 when multiplied with 16, you get 16 fours are 64. So 64 into 12m. It is very simple, don't get confused. I wrote 48 as 12 fours are 48. And that 4 when multiplied with 16, you get 64. So 64 into 12m plus 64. Now on the whole, you take 64 common, then you get 49k minus 12m plus 1. So this is a multiple of 64. 64 into some integer. So it is a multiple of 64. Any multiple of 64 is divisible by 64. Therefore, P of m plus 1 is true. This is step C. So from A, B and C, using principle of mathematical induction, P of n is true for all n belongs to n. This is the conclusion.